of, then you want an plus 1 over an. Okay, now what I have, I don't know if it's not going to be, probably going to be different than what you have, is my an's are, this is weird, okay, it's 13 to the n plus 1. So I'll put the an first. 13 to the n over n plus 1 and 4 to the 2n plus 1. So if I add 1, I get that. If I add 1 to this, I get n plus 2. If I add 1 to this, I get 4 to the, we'll just write it like that, n plus 1 plus 1. And let's see. So this and this, they just reduce to 13. Okay. And then we have this goes to the top, n plus 1 up here, and this n plus 2 goes down here. Okay, now this goes to the top also. So that's 4 to the 2n plus 1. This right here, if you distribute the 2, you get 2n plus 3. Okay. So that's this part right here. Okay. Now we can try to resolve things. Okay, so now let's take a look and see what happens to each piece. This part right here is just going to go to 1. So we'll end up with, there's the 13 right here. And then here we have 4 to the 2n plus 3. This is 2n plus 1. The 2n's will just cancel each other off, and 3 minus 1 is 2. So down here in the denominator, we're going to get 4 squared. So 13 over 16 should be what we have. Because you subtract. To get that, you subtract. So equals 2. So that's how we get the 2 there. Okay. Does that resolve your question?
Yes, it does. Thank you.
Okay, so that's why it's convergent. So it kind of looks strange because at the beginning, maybe you think, oh, it's a 4. There's a 13 on top, and then there's a 4 on the bottom, but really, it's 4 to the 2n. This 2n makes a big difference. The 2 makes it 16 instead of a 4, basically. Okay, anything else? Any other questions?
No, that's all for now, unless you have some.
Nope, I don't have any. Okay. So let's see here. 11.8, we're getting into a power series. And they're of this form right here. So we've already experienced some of those, where you have a variable right there, Cn x to the n. And then more general, centered at a value a, where a is a fixed constant. In this case, a is 0 here for these series. And it would be Cn times x minus a to the n. Now, the thing about this is, so this could converge for some values of r, okay, and there's 3 possibilities. So that's why we're talking about convergence, where this converges, it is a function, f of x. It represents, or vice versa, there are some functions that you can represent with power series like this. And maybe one reason that you want to do that is because this is like a polynomial. Okay, as you can see, and it's an infinite polynomial though, but it is still behaves in some ways like a polynomial. This representation. So you have a function that can be represented this way, and so it could be useful to put it in this representation because it's like a polynomial. And polynomials, for example, can be integrated and differentiated. That's one of the first things you learn how to integrate and differentiate, and so that could be useful. Okay. Now, so it's interesting where it converges is an interesting question and valuable. So there's three possibilities. The first one is that it only converges at x equals a. Okay, so like for example, if I had let's say n to the n, x to the n, then that's only going to converge when x is 0. Okay, so a is, in this case, a is a here, in this case, right here, a equals 0, in this case right here. Because this is kind of like x minus 0. Okay, and the second case is it converges for all x. Okay, and an example of that one would be x to n over n factorial. And this actually converges to the exponential function, but for all values of x, it converges. And then the third case is that there is a positive number r, such that the series converges in for x minus a less than r, an absolute value, or distance between, this is distance between x and a. So it converges when the distance is less than r, but diverges when the distance is greater than r, right here. And then, so what this looks like is like if this is a, and this distance is r, and here's r again. So this point's x plus r, this point is x minus r, I'm sorry, a plus r and a minus r. Then it will converge everywhere in here and diverge out everywhere outside. But then at these endpoints, it could do either thing. Okay. So we'll talk a little bit about that on here, the interval of convergence. Okay, so what you typically would do to find the radius of convergence, there's a couple of tools. There's more tools, but there's two to just kind of help you get started with in this section, which are the main ones, the standard ones. The ratio test and the root test is you use this to find r. Okay, and then you have something like this, which is, like I said, is an interval right here, an open interval. You know it converges in there, you know it diverges outside. And then you check the endpoints right here. Okay. So you check the endpoints and determine if they converge. So if it converges at neither of the endpoints, then this will be your interval of convergence. If it converges at the right endpoint but not the left one, then this is. Left and not right, this is. If it converges at both endpoints, then it's this. Okay. Now, let me talk a little bit about the ratio and the root test. Okay, so as you recall, this is the ratio test. It's the limit as n equals to infinity of a n plus 1 over a n in absolute value. So in the case that we're looking at, though, our a sub n is c to cn, x minus a to the n. And so our n plus 1 is just adding n plus 1 to each of those. And these two reduce to this because we're taking the opposite value. And then these reduce to that, or is this, an opposite value. Okay. And so what happens in the when L is less than 1, the series is going to be absolutely convergent. So when this is less than 1, when that's less than 1, then we have that's less than 1 over the limit as n goes to infinity of c n plus 1 over cn. Okay, and that's going to be your radius of convergence. So this will be your radius of convergence. So your radius of convergence will be 1 over this, or if you want to just go like this already, it'll be that. Okay, and then likewise right here, or the radius will be 1 over the limit. Okay, and that's just these two right here. We rely only on this term here to get it, because these are all the same for all these series. Okay, and then when L is greater than 1, the series diverges. That means when you're greater than, you're outside this R, then you're going to be divergent. And when L equals 1, the test is inclusive. So those are just going to be the two endpoints, and you just check them to find the interval of convergence. Okay, so, but the thing is that R is the radius of convergence. And here's two ways that you can find it. Okay, or you can just like, or you can, a third way would be to use this right here, L less than 1, to get something like this. And then, well, you find L this way, and then you make this less than 1, and then you isolate this on the left-hand side, and then this over here, whatever this right here is going to be radius of convergence. Okay, so let's do some examples before we get too caught up in this. So going to the homework, number 1, find the radius of convergence. And we have -1 to the n. Oh, and the interval of convergence. Okay, so both things. And so here's our first candidate right here. And so here we're going to apply let's apply the ratio test, okay? So that's the limit as n goes to infinity of a n plus 1 over a n. And a n plus 1 is going to be, you take -1 to the n plus 1, x to the n plus 1 divided by the 7th root of n plus 1. Okay, and then you're dividing by an, which is just exactly that. Like that. Okay, now since we're taking the opposite value, you can basically disregard both of those. One will be positive, the other will be negative. So the quotient is going to be negative, but it doesn't really matter because you're taking the opposite value. So you can just throw those out. And you can throw those out independent of each other because they're just one. They're just one in magnitude each. Okay. These two are going to reduce to just x. Okay, like that. So those two reduce to x. So it's x n plus 1 over x to the n. That's x. You're taking the opposite value, so opposite value of x. And these guys in the bottom, though, So this and this, they go to 1. So the quotient of those goes to 1. Okay, so 1 divided by the other just goes to 1. So you just end up with this right here. And that's going to converge when that's less than 1. So the radius is of convergence is going to be 1. Okay, because you just have that. Now you check now you check the endpoints, because here you've got 0 in the middle and 1 and -1. So you check 1. If you plug a 1 into here, we have, that's a 1 to the n. So that's just -1 to the n over the n through the 7, and the 7 through the n, I mean. And this converges by alternating series. So this one works. And then if you check -1, then you're placing a -1 in here. And that they cancel each other out, so they just become 1. And then down here we have n to the 1/7, and that diverges because it's a p series, and that is less than or equal to 1, so it diverges. So the interval of convergence will not include -1, but includes 1. Any questions about that one?
So I'm sorry, can you explain what does the 1 mean? Like the one in purple?
Okay, the one in purple?
Yeah.
What that is if you take the limit as n goes to infinity of, okay, what happens is this is going to go all the way to the numerator. This goes to the denominator. Okay, so you have the 7th root of n over the 7th root of n plus 1. That limit's going to be 1. And that's what that is.
Okay, thank you.
Okay.
And then also, sorry, how did we know to make the absolute value of x less than 1?
Because that's the standard what you do. You calculate either this or this, and then make it less than 1,
Okay.
because that's where it's going to converge.
Okay.
You just calculate that. You make it less than 1. So the thing is that this just turned the limit. All this limit here just turned out to be 1. So that's kind of a special case right there. Yeah. So in other words, let me write it right here. So it comes from L less than 1.
Okay.
Okay, so let's take a look at number 2. So here, so do the same thing. So L is the limit as n goes to infinity. And well, I guess we better use the ratio test. The root test is not going to work. The root test would have worked out okay with the previous one, but let's use the ratio test. I guess I better write it out. Hold on. Okay, so our AN is just, you can just copy this down right here. And then add 1 up here. So adding 1 here gives you n plus 4. And adding 1 here gives you 5, n plus 1 factorial. Okay, so now a few things cancel, like these 5s are going to cancel or reduce. And this one, let's see here. Okay, this and that reduces, so n plus 4 minus n plus 3 is just 1, so x to the 1. That's going to be this. And then you have this other part, which is this n factorial goes up here, and the n plus 1 factorial goes down there. Okay, and that's going to be, the limit as n goes to infinity of the absolute value of x over n plus 1. Because n plus 1 factorial over n factorial is just n plus 1. Okay, so this is x hat. Now, no matter what x is, as n goes to infinity, this is going to go to 0. And so when you do this, you come up, what this means is that your radius of convergence is going to be infinity. Because no matter what x is, it's going to converge. Okay, so no matter what x is, this series will converge. Okay, so it converges for all x's. And that means your interval of convergence is going to go from negative infinity to infinity as well. Okay, any questions about that one? Okay, so those are both really kind of extreme cases, or kind of weird cases, because this is just out of 1 and this is that. So I'm just trying to teach you a few things as we go along. Okay, number 3, that's just going to be a little bit different. Find the radius of convergence of that one, and radius and interval of convergence. So we can do this with the ratio test if you want, or do you want to do the root test? Let's do the ratio. Let's do the root test, okay? Let's do the root test. The ratio test will give you the same result, by the way. Okay, so you have limit as n goes to infinity. Now you're taking the nth root, so that's going to be a 6. Then you have the nth root of n squared. And then you have the nth root of, no, nth root of x to the n is just going to be, or the absolute value of x to the n is just going to be absolute value of x. Okay. This one right here goes to 1 as n goes to infinity. So you get 6 times absolute value of x. Okay, that's your L. Force that to be less than 1. And you have x less than 1/6. And that means your radius of convergence is going to be 1/6. Okay. Now, so now your center is 0 because this is x minus 0 to the n, and you have 1/6. You add and subtract 1/6 from that, from the center, and you get positive 1/6 and negative 1/6. So we're going to check the endpoints. First of all, 1/6. When you set x equal to 1/6, that is going to give you 6 to the n squared, and then 1/6 to the n, which is going to be that. And does this converge or diverge?
Diverges.
Yeah, that diverges. So that means that this one's out. And then negative 1/6. That's going to give you negative 1 to the n squared, which also diverges. So that's out as well. So that means that your interval of convergence is going to be negative 1/6 to 6, not including either endpoint. Okay, any questions on that one? Yeah, so once again, when you set L less than equal to 1, that gave us the absolute value of x minus a, which is just x in this case, less than 1/6. So the radius of convergence is 1/6. Okay, let's go to this one right here. And again, we can use the ratio, the root test if you want. Yeah, we can use the root test. So here we have the limit as n goes to infinity of the nth root of the absolute value of a sub n plus 1. No, a sub n. What am I doing? I'm putting this plus 1 there. Okay. So we have x plus 6 to the nth over 6 to the n log of n in absolute value. Okay, now when you take the nth root here, when you take the nth root of x plus 6 to the n in absolute value, that's going to give you the absolute value of x plus 6. Absolute, nth root of x 6 to the n will be 6. And you'll have the nth root of natural log of n. This piece converges to 1 as n goes to infinity, because the nth root overcomes the natural log of n. So you just get x plus 6 in absolute value divided by 6, and you set that less than 1, and that leads to this. So what's your radius convergence?
Just 1. No.
6 from here. It's going to be 6 from that, from this right here. Okay, now your interval of convergence, okay, because your center is -6. Okay, so let me make a note of that. Different color. A is -6. Okay, so that's your center. Your radius is 6. So you add 6 to this, you get 0. You subtract 6, you get -12. So your interval is going to go from -12 to 6. It's just a question of whether you include the -12 or not, and whether you include the 6 or not. Okay, so let's start with -12. Let's see what happens there. When x is -12, then we have -12 plus 6. That's -6 to the n over 6 to the n log n. That reduces to -1 to the n over log n. Okay, now log n goes off to infinity. So 1 over log n goes to 0. And it goes monotonically. So that means this will converge. So that means we include the -12. Okay, so this part right here, we include it. Okay, and then when x is 0, we have this. We have put a 0 here. This gives you 6 to the n over 6 to the n log n, which is 1 over log n. And does this converge or diverge? It diverges. So that means that you're not going to include the 6. Okay, any questions or concerns about that one? No comments?
Could you explain one more time why it's not including the 6 and why it's not a 0 instead? Because our interval, we have it going from -12 to
Oh.
0.
Yeah. Why did I put that should be a 0.
Oh, okay.
Sorry about that.
No, it's fine. I thought I was missing something, but
-12 to 0. Okay, great. I'm glad you guys are paying attention. Okay, let's look at number 5. Find the radius and interval of convergence of this one. Okay, so here we have A and a B in there. Whoa. Okay, let's see. The easiest one here is probably the root test again. So you have the nth root of A sub n. Okay, which is n times x minus a to the n over b to the n. So b is greater than 0, so we don't have to worry about the absolute values on that. So when you take the absolute value of that, you don't have to worry about x minus a and taking absolute value of that. Okay, and that will, so that'll be that. Okay. So when we look at each of these pieces, we have the nth root of n. Here, the nth root of this is just going to be x minus a in absolute value. And the nth root of b to the n will just be b. And this piece converges to 1 as n goes to infinity. So we get this right here. And when you set that less than 1, you get x minus a absolute value less than b. So that means that the radius of convergence will be b. Then, for the interval of convergence, it's going to be centered at A. That's the center. And A plus B and A minus B, or like that. Okay? So your interval is going to go from A minus B to A plus B. It's only a question of whether you include one or the other, or both, or neither. Okay? So first you can set x equal to A minus B. And that gives you so x is A minus B, so that means an A minus B minus A to the n, which is and b to the n. B to the n. Those guys are going to cancel, and you have this guy here, which diverges. Okay, so that means that we're not going to include the A minus B. And not include it by doing that. So we'll go ahead and do that. And then, or let me just do it in red, or that. Right? And then for the other one, when x is equal to A plus B, we have n over b to the n. This piece right here, when you put an A plus B in, wait a minute. You get it b to, okay, so this one right here, I'm sorry. In this previous one, I messed up a little bit because this is negative b to the n, so it should be like this. But still, that's going to diverge. I'm not going to go to infinity, but it's going to diverge. This one also diverges, which means that you're going to have the right parentheses like that because it diverges. So you're not going to include the A plus B point. Okay. Any questions or concerns about that one? Okay, great. Let's look at number 6. Okay, number 6. When you see factorials, then you have to do the ratio test. That's not gonna, nothing, other things are not gonna work too well. So, L is the limit as n goes to infinity of a n plus 1 over a n in absolute value. Put all this in the denominator. And then put n plus 1s up on it in the numerator. Hang on, I forgot the absolute value. Okay, now, so let's see here. I can take that off. N plus 1 factorial over n is just n plus 1. Okay, and this one is just going to be 6x minus 1 in absolute value, because it's n plus 1 in the numerator and in the denominator, so there's that. Okay, now as n goes to infinity, this is going to go to infinity. Okay, so that means that the radius of convergence is going to be 0. Okay, because infinity is always greater than 1. Okay, so, and it's going to be infinity for every value of x. This is going to happen. So the radius of convergence is going to be 0. And that means that the interval of convergence is going to just be our center point. And the center point here actually is not 1. The center point is actually, to get the center point, you set this equal to 0. Okay, so A is 1/6. Now it does converge there because when you set x equal to 1/6, this is 0. And so it doesn't matter that these guys are just like going to infinity like crazy time, because this is just 0. So you're just multiplying whatever big number you have here by 0. So you only have like the first term in the series, which is like a 1. Okay. But this series is not useful because it only converges at that one point, which means that it's really like, what's the point? Okay, any questions about this? Great, let's move on to the next one, number 7. Okay, find the radius and interval of convergence. Okay, so this one we're going to also have to use the ratio test. It's a ratio test. I'll skip the formula. Okay, so you put the an term in the bottom like this. And then the n plus 1 term in the numerator. And you have this extra term right here. Okay. And all that's absolute valued. Okay, now let's see what happens. This and this reduce to just absolute value of x. This and this reduce to n plus 1. And then And then finally, this and this, all of these terms cancel out all of those terms, and you're only left with this term here, but it's in the denominator. So like that. 6 times n plus 1 minus 1. Now, as you go to infinity, you're going to get absolute value of x over 6. Okay, because all of this goes to 1 over 6. Okay, and so then you take that, and it's 4 set less than 1, that gives you this. Okay, and so that's telling you that the radius of convergence is 6. Okay, then your center is 0, because it's just x to the n. And so let's see here, 0 there, and you add 6, you get 6, you subtract 6, you get -6. So that means your interval of convergence is going to go from -6 to 6. But do we include 6, or do we exclude the 6? And then and also likewise -6. So let's take a look at 6 first. So that's going to give us, whoa. Okay, so this is kind of tricky because you want to know how we don't know how that's going to work. And let's see here. Wow. Well, let me tell you what you want to look for, okay? The way that you get convergence, okay, the way that you can get convergence is you have to have, there's a couple of ways. You have to have these, but you have to have these things going to 0, okay? You have to have these terms going to 0. And this does not happen here. This does not go to 0. This goes to 1. This converges to 1. Okay. Let me see. How can, because you don't have anything in the denominator that's bigger than the numerator. Because you're just adding another 6 times something, like 6n minus 1 on the front, and this is just putting more 6s, and those 6s are gonna just kind of neutralize each other as you keep going more and more out, even though you're being subtracted by some numbers. And then this n factorial will reduce that, will neutralize the n's. So this doesn't converge to 0. Doesn't converge to 0. And so that means that the upper endpoint isn't going to work. And then also, by the same reasoning, you're just putting, when you put a -6n, you're going to end up with this right here. Well, you have a -6 to the n, but that's a -1 to the n times 6 to the n. And again, by the same logic, doesn't converge to 0, even though it's an alternating series, but you need it to converge to 0 to have a chance. So that means that you got this right here. So that's going to be your interval.